Hello, someone out there. Yeah, hello. Am I audible? Kindly respond. Who is this? There was some technical issue due to which it got delayed. We just start in a short, within 5 minutes. But I just shared to others also to join. May I know who have joined? Can you just text your name? Yeah, hello. Am I audible? Kindly confirm. There was some technical issue, but sorted out. Thank you for your patience. Am I audible? Okay, we'll start in 1 minute, 1 2 minute. Yeah, thank you very much for your support. Now we'll start with the class. How are you all? How are you? How's your preparation going on? Mm-hmm. Manvita, okay. There are some people join. Good, good to see. But I also join here. Okay, now we'll start the class. Yeah, fine. So now let us proceed with the class. Ready? Okay, fine. Hi, dear students. Welcome you again to our YouTube channel, Math Universe with Dr. Naseer Ahmed. As said that today we are going to have a live session on application of derivatives followed by integrals and differential equations, one marker questions, that is fill in the blanks and um, multiple choice questions. So with that we are going to start. Let us just take the marker. Yeah, we are ready. So thank you for your support. Now let us start with the class. Now, see, I'm going chapter wise. First, we are going to start with application of derivatives. So let us take the chapter application of derivatives. Let I open the question set, and again the question set will be sent to you. Means the link will be shared in the WhatsApp for the same. Okay, fine. So let us start with the class. Okay, fine. So coming to the first chapter of today's application of derivatives. Let us have the chapter name. Okay, in short we call AOD. Fine. So coming to the first topic, we have got rate of change of quantities that we also call as rate measures. Is my voice audible? Kindly confirm once. Is my voice audible? No, it's not online remedial. It is important questions for 1 marker we are discussing. Okay, fine. Kindly confirm, is my voice audible? Yeah, it's audible. I can hear. Fine. Yeah, fine. So let us start. See, we are going to have with the first concept rate measures from application of derivatives. Now, usually, since all of statement problems, I have seen students struggling with the data, what it actually stands for. So coming to rate of change of quantity, that is rate measures, what we also say as rate measures. I'll just give you a very easy way. How are you going to differentiate between is it a length, volume, or a area? See, if I talk about length, what are the different units? Is it centimeter or kilometer? I can have also have millimeter, then centimeter. Let's go unit wise, and kilometer. If I talk about area, it can be okay. Then we usually don't have this. Directly we have a square centimeter, then square kilometer. Okay. Then coming to volume, usually you're not having any problem on this, so let us not worry about this. Centimeter and kilo centimeter sufficient. Here, cubic centimeter, and this is also very rare, but anyway, let us have. Now, coming to our real world, we are depending on time. Whether now, for example, today it was 7, but we are yet to start, no? But anyway, in the clock it is showing 7. So we are depending on the time, and time is not depending on us. So time is the independent factor. So rate of change of quantity with respect to time, t. As I said, with respect to time, so you can see centimeter per second, kilometer per second. So at what per second, how much length it is given. Similarly, rate of change of time with respect to area. As soon you see square centimeter per second, oh, square centimeter stand for area, then per second, nothing but time. Again, here also same. Okay. As soon I give rate of change of volume with respect to time. And in this, we should understand that if y is increasing, okay, let us suppose that I have a quantity. If y is increasing, derivative of that will be positive as x is increasing. Okay, that's important. As x is increasing. Point number one. Point number two. If y is decreasing, then derivative will be less than 0, as x is again what increasing. In both the instant, x will be always increasing only the function y will be increasing or decreasing. Okay, now having this information, let us move on to the problem which I have chosen for the people. Okay, now let us go ahead with the problem. Okay, now let us proceed. Now, I have taken all the problems from question bank, which is released by PU board, and I'm also giving the same numbering as per the question bank itself. Okay. So in this regard, we have got question number 5 from application of derivative chapter. Question number 5. I'll be sharing this PDF what I'm solving after the class gets over. In the description, I'll be sharing the link through which you can download this PDF. Okay. Now, question says, listen the question. The radius of a circle is increasing at the rate of zero point 0.7 centimeter per second. 0.7 centimeter per second. What is increasing? The radius of the circle. We know that radius of a circle is denoted by r. So it's a change of length with respect to time. So dr by dt. I hope this is clear how to get rate of change of radius with respect to time. Then the rate of increase of its circumference is they're asking, and they're given here pi centimeter per second. So I have to find that number. Since the problem is on circumference of the circle, so c is equal to 2 pi r. Since I want rate of change with respect to time, So differentiate this with respect to time, then we are going to have dc by dt is equal to 2 pi is a constant. Be careful, here c is a dependent variable. Okay, c and r both are depending on time t, so c and r derivative will be 0. Derivative of c with respect to t will be dc by dt, and 2 pi is a constant, keep as it is. Derivative of r will be dr by dt. So 2 pi as it is. Then coming to dr by dt, 0.7. Let us write properly. Into 0.7. So 2 into 0.7 will be 1.4 pi. And since you have got what? Circumference. So it will be centimeter per what? Time. Second. You can see pi centimeters given. So what's missing there? 1.4. So here the value is 1.4. That is matching with the option blue. Before I proceed, kindly comment any doubts. Any doubts? Okay, fine. Now let us proceed with the next. I hope there is no doubt. Moving on to the next problem. See, from this chapter, application of derivatives, we are getting 3 questions in MCQ. 3 questions, not 1 or 2, 3 questions. So I'm going to give more time for this. Surely for other, we have got integrals, we have got 1 question. Differentials, we have got 1 more question. Totally, we have 2 questions there also. Let us move on to the next problem. Kindly listen. Now, this is question number 6. Question says, I will read the question. The radius of an air bubble is increasing at the rate of half centimeter per second. What is increasing? Radius of the air bubble. Air bubble will be in which shape? Spherical. Okay, remember that. Then the volume of the bubble increasing when the radius is 1 centimeter. When the radius is 1 centimeter, I have to find rate of change of the volume. And here, this is rate of change of radius, they said. Since radius we have taken as r, and you can see it is changing with respect to time. So this will be d derivative of r with respect to time t. Now, what is the formula to find volume of a sphere? They said air bubble, which will be spherical in shape. Volume of the sphere will be v by means 4 by 3 pi r cube. So now we have to differentiate this with respect to time t. So derivative of this with respect to time t will be dv by dt is equal to 4 by 3 pi. 4 by 3 into pi is a constant. So we have kept the constant as it is. Derivative of r cube will be 3r square into derivative of r with respect to t. 3 by 3 will get cancelled. 4 pi into r value is 1, so 1 square. Derivative of r with respect to time t is half. Substitute 2 ones are 2 twos are. So answer is 2 pi. And since we have got derivative of v with respect to time, v stands for volume, so cubic centimeter, and time per second. So the volume of the spherical balloon is increasing at the rate of 2 pi cubic centimeter per second. So if for each centimeter, I mean to say for each second, volume is changing by 2 pi. For 2 seconds, 2 into 2 pi will be 4 pi. For 10 seconds, multiply 10 here, 10 into 2, 20 pi. Okay, it is changing. So that is going to give us the rate of change of the quantity. And actually, in option A as well as in option C, 2 pi is given. So it's a printing error what they have typed. Okay. So I hope this is clear. I hope all of you are following. Before we go ahead, any doubts? Which 5 marker are best? See, if you ask us, no, all 5 marker are best only. Now the thing is, how will you want to go ahead and study, and which is easier for you. Okay, fine. So now let us move on to, I am solving from application of derivatives. Today's session is on, dear student, today's session is on one marker question of MCQ as well as fill in the blanks. Okay, we are dealing with that. Clear? Now, let us move on to increasing decreasing function. Listen carefully. Quickly, we'll recall the concept and then we'll flow with the problem. Ready? Now, coming to, when do we say a function is increasing function? Okay, let us just know the theorem. First, a function is said to be increasing. Just see this graph. As and now I'm going right of x values, the graph is also going up, 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 up along y-axis. This we call increasing. So here, whenever a function is increasing, y equal to f of x is increasing, it is said to be increasing if f dash of x is greater than 0. For this one, it will be strictly increasing. If I have got f dash of x greater than or equal to 0, then we say it is only increasing. Okay, I hope this point is clear. Now, decreasing function. When do we say a function is decreasing function? See carefully. This one you can see, and this as and how the x values are moving towards right, you can see the graph is coming down. This is called decreasing function. A function y equal to f of x is said to be decreasing. As and how x is increasing, the value of y should go on decreasing. And to verify how whether it is increasing or decreasing, it will be derivative. If I take, it should be negative. This will be strictly decreasing. This will be strictly decreasing, and this will be what? Strictly increasing. And this is only for the increasing. Okay, the arrow mark which I'm giving above now stand for increasing. The below arrow mark stand for decreasing. So f dash of x less or equal to 0, this will be decreasing. Okay, so we are going to use derivative concept, then we for the usual way. Now, having this, let us move on to the problem. See carefully. Question number 9. It says the interval in which y is equal to x square e power minus x is increasing is. They want the interval under which the function is increasing. So whether it is increasing or decreasing, one thing is very clear, we have to find the derivative. You can see here also. So now let us first find the derivative. If I find the derivative of this, it's a product of two variable function. We have to apply product rule. That's nothing but UV rule. What it says, see carefully. U into V, if I take derivative, this is my first function, this is my second function. Derivative of U will be U dash, then keep V as it is, then keep U as it is. Derivative of V is what? V dash. So, as per the order, this will be our function U and this will be our function V. So, one by one, we should differentiate. Derivative of x square. Recall what is derivative of x power n with respect to x. It is n into x power n minus 1. Yes or no? So, derivative of x squared, in place of n it is 2, so we'll get 2x. Okay, then 2 minus 1 will be 1 here. Then e power minus x as it is plus, keep x square as it is. What is derivative of e power minus x? It's a combo of two functions. First, derivative of e power x is what? E power x itself. So, e power minus x will be e power minus x itself. Then derivative of minus x, minus as it is, x will be 1. I hope this is fine. Now, what is common in this? E power minus x is common. Then here 1x, here x square, so x is also common. So remaining will be 2, then plus into minus is minus, x square. Here x is there, x square is there here. So only one more x is pending. I hope this is clear. Now I have to find under which interval this function is increasing. So I have found the derivative. Correct now? See, this is our exponential function. Exponential function is always positive. So there is no much role about exponential function. We have to only take the roots of this, and then we are going to go for Wavika method. I'm also going to teach you Wavika method today. Just see carefully. So find the roots of this. If I find, I'll get x equal to 0, and from here 2 minus x equal to 0. If we transpose, x is equal to 2. So plot on number line in ascending order the roots. And you can see here, since this is always positive, you can, whatever x value you choose, e power minus x will never be negative. I hope this point is clear. Now, how are you going to write the numbers? Till here clear? Till here clear? What I did? I found the derivative, then I equated to 0 each of the factors. Now what we have to do? See the x multiple. See the sign. What's x multiple sign here? Plus. And here what is then? Into. So multiplication. What is x multiple here? Minus. So what is plus into minus? Minus. So you should start from minus sign here. As soon you jump the number, you have to change the sign from negative to positive and positive to negative. So when I jump, it is positive. Again jump, negative. And this have the sign of what? F dash. So I want in the question they were saying for what they want for increasing. For increasing, f dash should be positive. F dash is positive from where to where? F dash is positive from for x belong to 0 to 2. 0 to 2 is there in which option? Option D. Okay. Presently, I have taken that problem where the powers are not even. We are not having any modulus. As in how we go on today, when power will be even, that time I will discuss this fact also. How to tackle for even power. For odd power, no change, same working. Kindly comment. Any doubt in this? Any doubt? Are you following? Is it clear? Okay. Fine. Now, let us move on to maximum minima question. Then we can have all the problem of that type. No need to copy the problem now. It will be anyway online present. First, we can listen the problem. Okay. Now, moving on to next part. Kindly listen carefully and pay attention. Now, next part is maxima minima concept, maxima and minima. All of you, listen carefully, pay attention. Now, coming to maxima minima. When do we say a function is maxima minima? See, let us take one graph. Okay. Graph will make us the things very clear. Okay. So, see, let's have the graph here. Now, let I name this graph one by one. Fine, no problem. See, here, I'm just labeling some points. Now, if you see, okay, and at D, whatever the value I'm getting, that also take as capital D. See this carefully. The function is first here. If you just see, which is the maximum value, largest of all. Largest of all is this. This is the absolute maximum we say. Absolute or only maximum value when we say it is largest of all. Whereas, let's say that I'm going to come back here. Yeah. So here we have E and corresponding point is here. And this is the least value. So this will be absolute minima or absolute minimum. When do we say absolute minimum? Least of all. Absolute maximum, largest of all. But if you see carefully here, in this neighborhood, A is largest of all. This we call local maxima. Local maxima. And the point A, which is giving us the local maxima, is known as point of local maxima. Okay. Similarly, sir, if you see B, you see, is going in this neighborhood. B is the least value locally. Entire value is E. So this is local minima. Kindly pay attention after this only problems. Okay. And here point of local minima. What is this point of local minima? When we say point of local minima, yeah. When we say point of local minima, it means to say that that point it is giving us the minimum value, local minimum value. When I say point of local maxima, that point it is giving us the local maximum value. And here, this small c is giving absolute maxima, so this is point of maxima. Point of absolute maxima. Absolute maxima. And this is the point of absolute minima. Now here we are going to have a problem to find absolute maxima, absolute minima. You just see carefully all this. If I draw a tangent here, no, here you draw, here you draw, here you draw. All these tangents are parallel to which axis? X-axis. Nothing but at this point C, if I say this curve is y equal to f of x, then derivative represents slope of the tangent. So at C, this line is a tangent and f dash of C is what? 0. Similarly, here also you see this is a tangent here, parallel to x-axis, and here f dash of B is what? 0. What I mean to say, whether you have got largest of all, least of all, or local maxima, local minima, if the function is continuous and differentiable, then derivative, if I take at that point, it is always what? 0. This we call critical points. What are critical points? If f of x is a continuous function, if y equal to f of x is continuous function, continuous NOUS, okay, continuous function, then either f dash of x is equal to 0 or f of x is not differentiable, non-differentiable. Only for those points we call the critical points. Now here, if you see all here, f dash is differentiable. But if I talk about y equal to mod x, see the graph of y equal to mod x. This, and here at x is equal to 0, y is also 0. So I'm going to have minimum value, but this point is not differentiable. So either it's not differentiable or f dash of x is not f dash of x is equal to 0. Now one most important point. See here. Observe here. Here also f dash is 0. This for this curve, no, x-axis is a tangent and slope of x-axis was 0. This we call the D, point of inflection. Point of inflection. Now what is point of inflection? It is a point at which the function derivative is 0, but that point is neither point of maxima, point of minima. Okay. One such example can be y equal to x cube. See this y equal to x cube. The graph of y equal to x cube, you see. X-axis is a tangent to this graph at x equal to 0. Yeah, I know. As soon as I say tangent, you see, size touching, no sir. Means it's cutting, no sir. Tangent means it should touch. That is the definition of a circle aspect. When we say tangent, it's a limiting case of secant. Okay, that I have discussed in our continuity and differentiability video. Okay. So now coming to all our problem, we are going to have critical points. When I say critical points, this can be a point where it can be point of maxima, point of minima, point of local maxima, point of local minima, or it can also be what? Inflection point. And one more thing, see here it is increasing, then decreasing. At this point here, it is changing its behavior. It's turning. See, it is going up. Now it is coming down. Again, it's going down. Then coming up. Again, from going up, it's just going down. It's turning. So this A, B, C, whatever point of maxima, point of minima is there, we also call turning point. Turning point. D is not called turning point. Only point of maxima, point of minima is known as what? Turning point. So A, B, C. Okay, let's mention here. Point A, B, C, and D are called turning points. Okay. Only at turning points you can have point of maxima, point of minima. Okay. Fine. And lastly, one more thing. See, here it is increasing, no? So when I say increasing, f dash is, this is increasing function, f dash is greater than 0, and here it is decreasing, so f dash is less than 0. I am going to go for one test known as first derivative test, which is talking about whether a function is, how it is behaving, increasing or decreasing. And by using first derivative test, I'm going to talk about local maxima, local minima. So whenever f dash sign is changing from positive to negative, you can see no, positive to negative. So the point at which it is changing its sign from positive to negative, that will be point of local maxima, and you are going to get local maximum value. Similarly, you see here at all this point, if you see, it is decreasing, nothing but f dash is negative. But after reaching this point, it is increasing, but f dash is positive. So whenever the sign of f dash is changing from negative to positive, the point at which is changing, that point will be point of local minima, and corresponding point will give, if I substitute x is equal to b here, local minimum value. I hope this point is clear. See, I will just, I would like you to see my finger. I know many times students are not able to grab the things faster. You just see the finger here. Okay, see carefully, and you have to say me whether with respect to the finger, is it increasing or decreasing. Okay, come on, see the finger. Say me, increasing or decreasing. I'm waiting for your chat box response. Come on, say me. See the hand, see the finger here, and say me, is it increasing or decreasing? You have to see the finger and you have to say me. But I come to that live. Yeah, I'm now live. Yes. See the finger here. Is it increasing? Can you see? Yeah, it is increasing. Nothing but f dash is positive. Correct now? As when I'm coming down, it is decreasing. Nothing but f dash is negative. So whenever you see that, see, for increasing, f dash is positive, and as soon as I reach and I'm just coming back, f dash is negative. So whenever the sign of f dash is changing from positive to negative, I repeat, positive to negative, then we are going to have point of maxima. Similarly, when the sign of f dash is coming from, see this, now it's going down, f dash is negative, now it's going up, positive. So whenever the sign of f dash, okay, is negative, then increases, nothing but positive, negative to positive, the point at which it is changing, turning, that point will be point of minima. Okay, so I hope this logic is clear. Now with this, let us start with the problems. Any doubts before we proceed? That's what I've explained here. But coming to critical points, it can be a point of maxima, point of minima, as well as point of inflection. Point of inflection is that point where you can see here the function is neither maximum or 0. The function is neither maximum nor minimum. That we call point of inflection. Is it clear? Kindly comment. Okay, fine. Now let's move on to next. Now moving on to next. Now only problems from application of derivatives. Let us move one by one. Okay. Now let us move on to the problems. Now only problems now. All concepts are done. Pay attention. Listen carefully. Now question says, question number 11. See carefully. Question number 11 says that the maximum value of mod x in R, maximum value of y equal to mod x. Coming to y equal to mod x, they want which value? Minimum value, sorry. Coming to minimum value, draw the graph. Now see, I said for critical points, it may not be differentiable also. Example is this. Now if I draw the graph of this, it just first comes down, then goes up. And this point is 0, comma 0. This will be point of what? Point of minima. By minima, see the value is decreasing and then up going up. No, so this is the least value compared to all least value, and this is minimum value or minima. So they want what's the minimum value. So the minimum value is 0. That is then option A. Option A is correct. Okay. Now you see next question. Question number 12. I will read the question. The maximum value of the function f of x equal to mod x is in R. Option A 0. Option B 1. Option C 2. Option D does not exist. Same function they have asked. Now they are asking maximum. Now see carefully, when they are asking maximum or maxima, this is never ending. It goes up. It's unbounded figure. Therefore, maximum value does not exist. What? Does not exist. So option, which one is correct? D is correct. Okay. Maximum value does not exist. Any doubt? Are you clear with this? I have taken one tricky problem. The problem QN means question from my end. Can you say me what could be the maximum and minimum value of f of x is equal to mod x, where x is belonging to -3, 4? What could be the maximum and minimum value? Yes. See, y equal to mod x, and here the graph, the value from -3 to 4. Okay, so the mod x graph, as you know, it is like this. So from the graph, the least value is here, nothing but 0, and the maximum value is here. And when x is equal to 4, what is f of 4 value here? Mod of 4 is what? 4. So minimum value is 0. Minimum value is 0 and maximum value is 4. Okay, so just see, now as soon as I have given the interval, it got bounded because I got an endpoint for x. Okay, that's what the reason. Now I took just one problem from my end to make you understand. Just see how the maximum value which does not exist can become it exists also. Okay, I hope this is clear. Let's move on next question. Okay, fine. Let's move on to the next question. All of you. Question number. Okay, fine. Question number 20. The function f given by f of x is equal to x square minus x plus 1 is option A, neither strictly increasing nor strictly decreasing on open interval -1, 1. Option B, decreasing on decreasing on interval half, infinity. Option C, increasing on R. Option D, increasing on -infinity, half. Okay, so it is talking about increasing, decreasing. So first let us differentiate this. Derivative is what? 2x, then minus x will be 1, and 1 is a constant, so 0. So we are going to get the derivative to be what? 2x minus 1. Correct? Yeah? Now, let I equate to 0 and find the roots. As soon as I find the roots, 2x is equal to 1, I can transpose here, or x is equal to half. Now we are not going to do the way we do in PUC because it's MCQ, so just you want the answer. Now we go for very common method. We got how many roots? Only one root, half. Now what we have to do? just see this f dash. Better you can see here. X multiples are positive. So start with plus sign and then what minus sign. So it means from minus infinity to half it is decreasing because the sign is of f dash. If f dash is negative, f is decreasing. Who is decreasing? F. And if f dash is positive, it is what increasing. Who is increasing? F. Now it is go by option by option. Okay, option by option. See carefully. Now option A says question number 20. No, neither strictly increasing nor decreasing from minus 1 to 1. Oh yes, see carefully. On minus infinity to half it is decreasing. Half to infinity it is increasing. But they are asking in option they are saying minus 1 to 1. See carefully. Minus 1 to 1. Somewhere minus 1 is here and 1 is here. So in this interval, minus 1 to half it is decreasing. Half to 1 is what? It's increasing. It's giving two different behavior. It should be either increasing or it should be either decreasing. So minus 1 to 1, it's neither increasing nor decreasing. Option A is correct. No, so I want to check the remaining option. No problem. Option B says decreasing on half to infinity. Half to infinity, f dash sign is positive. It's increasing, but they gave us decreasing. So option B out. Option C says increasing on R. No, on R it is not increasing. It's neither increasing nor decreasing. Okay. Next, on R means minus infinity. See, whenever they write minus infinity, comma plus infinity, there's nothing but what R. I would like to say R only. Then increasing on minus infinity comma half. Minus infinity comma half is what? It is decreasing. Okay. So very clearly option E is correct. Okay. Any doubts? Are you following? Okay, fine. Now let us move on to next problem. Question number 25. Question number 25 says the maximum and minimum values of the function. This function sine of 4x plus 3, maximum and minimum value of this we want. Now in the question is asking maximum minimum, here we have got mod and no need to differentiate. Whenever mod is there, usually you cannot think of differentiating. You'll get a kink. Already we have seen that. Now kink means sharp bend. Now what you can do is find the range of this. See under the mod what do we have? Sine 4x plus 3. We know that when I talk about sine, what is the range of sine? It is minus 1 to plus 1. Then we have plus 3. So add plus 3. Don't forget under inequality, we have learned that whether you add, subtract, inequality will remain same. So why am I adding 3? Because 3 is there here. So minus 1 plus 3 less or equal to sine 4x plus 3 less or equal to 1 plus 3. 1 plus 3 is how much? 4. Minus 1 plus 3 is how much? 2. Less or equal to sine 4x plus 3. They want under the mod. Okay, if I take mod, don't forget 2 to 4, all the quantities are positive. So mod of positive is again what? Positive. So there won't be any change after applying the mod. So this will be our minimum value. And this will be our maximum value. So let us go for the option, which is the correct option. They're asking for question number 25, maximum first, minimum second. See, be careful. I write the option for you. Here 1 comma 2 is the option A, option B is 4 comma 2, option C is 2 comma 4, and option D is minus 1 comma 1. So what I'm trying to comment here is, in this option you can see B and C, 4 comma 2 and 2 comma 4 is there. But they are saying first they want maximum, then they want minimum. Maximum they want first, maximum is 4. So each of the value here, no, first value stands for maximum, second one stands for minimum. So first they want maximum, then minimum. It should not happen in hurry. You have picked option C. If you take option C, it will be other way around. Maximum is 2, minimum is 4, which is incorrect. I hope this point is clear. Kindly comment. Any doubts? Is this clear? Okay. Fine, let's move on. Next problem. Okay, moving on to next. Question says, question number 30. It says, see carefully, the minimum value of, the minimum value, so fill in the blanks question, the minimum value of mod of x plus 2 minus 1. I want to find the minimum value of this. Again, we have to find the range of this. Range will give the answer better for this type of question. Now see one by one what you have to find. First, you have to find what is mod of x plus 2. Don't forget x is a real number, correct? No, x is a real number. Now, mod of x plus 2 is always non-negative. Mod will give always positive or 0. 0 means if the term inside the mod is 0. And this can be 0. If I equal to 0, you'll get x plus 2 is equal to 0 or x is equal to minus 2. So when x is equal to minus 2 plus 2 will be 0. That's what I would greater than or equal to 0. Then I want minus 1 also. Okay, add minus 1 both sides. Then I'll get mod of x plus 2 minus 1 get or equal to 0 minus 1. 0 minus 1 is minus 1. Mod of x plus 2 minus 1. See carefully. Other way of writing. See, if I write 5 is more than 2, this also means that 2 is less than 5. So let us rewrite in this manner so that no. See, whenever we have got this type of question of maximum minima, we have a habit that, see carefully, we have a habit of understanding things like this. Let us suppose I want a function f of x lying between two numbers a and b. Only then we say a is what? Minimum value. Minimum value. And this will say maximum value. So we have a habit of seeing the function between the inequalities. That's what I'm trying to write. And before I go ahead, this is point number 1. Point number 2, you see, and this will be very beneficial for you to remember. See, as soon as I write a less or equal to f of x less than b, f of x has attained a value but not attained b value. So only minimum value exists, and that is a. Whereas maximum value does not exist for f of x. Maximum value does not exist. You may say, sir, it is taking b value. No, it's not taking b value. It's taking less than b. Then you might say, sir, b minus 1. No, see, if I've got any function, for example, no, f of x is less than some 2. Okay, you can't say, sir, f of x is 1. No, I can have any number less than 2, like 1.9. Sir, then you fix to 1.9. No, I can say, can be 1.9999. I hope you got the point. It cannot be fixed when it is strictly less than. So similarly, let's suppose I got a less than f of x less or equal to b. Now b is the maximum value for f of x, and here f of x minimum value does not exist. Minimum value does not exist. Similarly, if I have got like this, a less than f of x less than b, so both value does not exist, neither maximum nor the minimum. Okay, f of x has neither maximum nor minimum values. So I want you to remember this point. In short, what you have to remember, you are going to say maximum value, minimum value, provided they attain the value. Otherwise, no. Okay, they should attain the value. Now you see here, I'm going to rewrite this. Minus 1. So if 5 is more than 2, same as 2 is less than 5. Second is minus 1 less or equal to mod of x plus 2 minus 1 less than infinity. It will never going to stop. So minimum value is minus 1. Minimum value is minus 1, and maximum value does not exist. For this, maximum value does not exist. I hope this point is clear. Maximum value does not exist. Okay, so anyway, I have answered both in place of only minimum. So maximum value does not exist. Question number 30 done. Now question number 33, you see. Question number 33 is saying, okay, I hope there's no doubt. Okay, question number 33, you see, they're asking in question number 33 maximum value of sin x into cos x. Maximum value of this. See, actually, when trigonometry sine and cos comes, no, best way is finding the range. But for finding the range, we should have only one function. We have two functions. But recall multiple angle formula. Is it not sine 2x is 2 sine x into cos x? Yes or no? Huh? Now, since I've got sine x into cos x, this additional 2 cross multiply. So I'll have sine 2x divided by 2 is equal to sine x into cos x. So I can rewrite this one as only sine 2x divided by 2. Now I have to find the range of this. Now how to find the range of this? Very simple. First we have sine. What is the range of sine? Don't forget sine value varies from -1 to 1 close interval. Then we have half. So divide by 2. I'm trying to make the middle term this expression. This expression divide by 2. So 2 being a positive, inequality will not change. So minus half less or equal to sine 2x by 2 less or equal to 1 by 2. So this will be going with this one, this will be minimum value, and this will be maximum value. I hope you are able to see that we are not differentiating. Without differentiation also we can get the answer. That's the motive of this class presently. So now question number 33, they were asking only what maximum value. What's the maximum value? We have got half. So half is the maximum value. It's a fill in the blanks question, half. Okay. I hope the things are clear. Any doubts? Okay, right is the board. So kindly remember this. So whether to maximum or minimum, they have to attain the value. Attaining the value is mandatory. Without that, nothing is possible. Okay. Now just without that, we cannot comment about maximum, minimum. Now moving to next problem. See carefully. Question number 31 says the max 34. I mean to say 34. Question number 34 is saying what? If x plus y is equal to 10, x plus y is equal to what? 10 for a while. Let I close this. Okay. There is one more marker here for a while. Okay. Let's proceed. Now the question says, that I read the question. Question number 34 says, if x plus y is equal to 10, it is given here, the maximum value of x into y, they want maximum value of x into y. Okay, fine. You can see you have got two variables, but our syllabus is one variable function. Surely, I want maximum value, so I'll take this as product to p is equal to x into y. I have got two variables, but they're given this to make it one variable. So solve for y. Y is equal to 10 minus x. You can solve for x also, but then you'll have only y. So you should be extra precaution to differentiate with respect to y. But since we have a habit of always differentiating with respect to what? X. So just keep everything in terms of x. So x as it is. In place of y, 10 minus x. Now differentiate. If I differentiate with respect to x, p is representing both the variables. So p is a dependent variable. Derivative of p with respect to x. Then I have to apply UV rule. Derivative of x will be 1. 10 minus x as it is, plus keep x as it is. Derivative of 10 is 0 minus x will be 1. So 1 into 10 minus x is 10 minus x. Then x into minus 1 is minus x. So I will get 10 minus 2x. Now I want to find the critical point. So equate this derivative to 0. When I equate to 0, 10 minus 2x is equal to 0. Transpose here. 10 is equal to 2x. 2 ones are 2 5s are. X is equal to 5. Now the question mark is whether x equal to 5 is point of maximum, point of minima. For this, we are going to go for first derivative test. What it says for that, first plot number line and write the critical point. Now see carefully. Come to the derivative step and see the sign, x sign. What's the x multiple? -2. So you should start from minus. Last time we had one positive, then we started with positive. So negative here. As soon as you jump, give plus sign. These are the sign of what? F dash. If f dash is positive, the function is increasing. And after reaching 5, the sign is negative. So the function f dash sign is negative. So the function is decreasing. So it's from increasing to decreasing, and you have got here maximum value. So this x is equal to 5 is what? Point of maximum. Point of maxima. Then what? I want y value. You can just put here. No need to find y value also. You can put here. So if also I put x is equal to 5 in equation number 1, we are going to get p is equal to 5 times of 10 minus 5. 10 minus 5 is 5. 5 5 are 25. Therefore, the maximum value is 25. Okay. I hope it's clear. Any queries? Okay, let us move on. Just a second. Yes. Let us move on to the next question. Fine. Listen carefully. The next question says, let us take a problem on critical points. Okay, critical. I mean to say point of inflection. Question number 39 says, it's an assertion reason type question. Assertion A is assertion A says the maximum value of the function f of x equal to x power 5, okay, in the closed interval -1, 1 is attained at its critical point x is equal to 0. Critical point is what? A point at which the function can be maximum, minimum. It can be a point of inflection. In short, it should be f dash should be equal to 0 or derivative does not exist. So they are saying the maximum value attains at critical point. But please remember, whenever you have got any polynomial of odd power, 2n is even. 2n minus 1 is what? Odd. When n is equal to 1, you can see 2 1s are 2. Okay? I like press here. 2 when n is equal to 1, 2 1s are 2, 2 plus 1 is 3. So I'll get x cube. When n is equal to what? 3. 2 3s are 6. Before that, this is for which value? N is equal to 1. If I take n is equal to 2, what x power I'll get? 2 2s are 4, 4 plus 1 5. Nothing but all odd powers I am going to get. The graph of that will be similar to x cube. This is your y equal to x cube. Okay, now y equal to x power 5 will be like this. Okay. So ultimately you can see that x equal to 0. Let's write again here. X power 5 graph is this. And at x equal to 0, the graph is not having any maximum value. It's just increasing, increasing, increasing. So statement assertion is false. Assertion is false. We're not having any maximum value at x is equal to 0, critical point. Actually, x equal to 0 is point of inflection. Point of inflection. Okay, now let's come to reason. What do we have in reason? Reason for this question is reason are the local maxima or local minimum values of a function can only occur at corner points. Can only occur where? Corner point. That's what I give the concept. Yes, it's only occur corner points, and this is true. So statement one means assertion is wrong and reason is true. So option A is correct. Option A said yes, yes, assertion is false and reason is true. Yes, that is correct. Now let us move on to the next question. Kindly make a note. Now moving on to next question. Question says the absolute maximum value of this. The absolute maximum value. Where is the pen caps? Okay, no problem. The absolute maximum value. Question number 44. We want the absolute maximum value of y is equal to x cube minus 3x plus 2 in the closed interval 0 to 2. See, when you're talking about the closed interval 0 to 2 and you want the absolute maximum value, the procedure will be like this. Just take the question, find the derivative and equate to 0. This is for what? Absolute maxima and absolute minima. Only for this work is what? You have to find the derivative equal to 0, and let us say you will get some point, and this question is given in the interval, closed interval a comma b. So you'll get some point c, d, and those belongs to a comma b. Then you have to find what? F of a, f of b, f of c, f of d. Even the endpoints also should be taken into consideration. So here maxima or maximum value will be largest of, I'm giving the concept here, largest of f of a, f of b, f of c, f of d. Okay. Whereas if I want minimum value, the minimum value is given by least of, again this, and see here we not get only 2, it can be 1 also or it can be none also. None means what? The function has not got any derivative equating to 0, nothing but, see, as soon as there is 0 is what? The meaning the line is parallel to x-axis, that case is not there if it is not equal to 0. So here again we will find and see which is the largest, f of a, f of b, f of c, f of d. Now let us move on to this problem. This given question we can always say it is f of x which is equal to y. So f dash of x I can simultaneously equal to 0. So derivative of x cube will be 3x square. Then minus as it is 3x will be 1. 2 is a constant, so 0. We will have 3x square minus 3 equal to 0. Transpose here. We will have 3x square is equal to 3. 3 will get cancelled. Or x square is equal to 1. X is equal to plus or minus 1. Whatever the points we are getting, that should be there in the interval. Only that point we have to consider, because in this interval they are talking about very clearly x will belong to, okay, I mean to say very clearly x is equal to 1 belongs to closed interval 0 to 2. But minus 1, x is equal to minus 1. X is equal to minus 1 does not belong to closed interval 0 to 2. So only have to check this expression for 1 is 0 and 2. So f of 0, put in this 0 cube 0 minus 3 into 0 plus 2. So the answer will be f of 0 is equal to 2. What is f of next one? Put here 1 cube minus 3 into 1 plus 2. So 1 cube is 1, then minus 3 plus 2. 1 plus 2 is 3. 3 minus 3 is what? 0. Next, 2. F of 2. Put here 2 power 3 minus 3 into 2 plus 2. 2 cube is 8 minus 6 plus 2. So 8 plus 2 is 10. 10 minus 6 is how much? 4. So now in this, which is the largest term? This maximum value. And which is the least? This minimum value. Okay, now let us see which option. So they want the maximum value, and maximum is 4, and that option is option C. So option C will be correct. Okay, kindly make a note of this. Okay, first you make a note, means later on you can copy. I thought I will just leave the space so that you can have a look. Now, moving on to the next problem. See carefully. The maximum value of 3 sin x plus 4 cos x is question number 56. The maximum value of what? 3 sin x plus 4 cos x. Okay. Now, you should understand here, without differentiation also we can get the answer for this. I'm going to give you a note that is always going to help you to get the answer faster. What's that note? See, range of, see, as soon as you find the range, no, we get maximum value also, minimum value also. So range of a cos x plus b sin x plus c is, as a note you can make a note, is given by c minus square root of a square plus b square comma c plus square root of a square plus b square. This will be the least value, this will be the largest value. So now, since let's find both, let's have a practice of both. Now see, a is cos multiple, so cos multiple is 4, so this is your a value. B is sin multiple is 3, so this is your b value. And in this entire expression there is no c, so c is equal to 0. So now in both the cases we want root of a square plus b square, as you can see here. So a square plus b square. So root of a value 4 with the square, b value is 3 with the square. So 4 square 16, 3 square is 9, root of 25. What is the 25? 5. Therefore, the range will be, anyway, c is 0. So now see, this value, no? C is 0. 0 minus root of this value is 5, comma, c is value 0. And this value is what? Root 5. This entire value is what? Root 5. So 0 plus 5. So the answer is minus root 5 to plus root 5. And this will be the minimum value. And this will be maximum value. I hope this is clear. So now let us move on and just see which is the correct option. Oh, yes. So option B, minimum value. Some comment has come for a while. Let us see the comment. Okay, fine. It was a whole problem, I think. Okay, fine. Now let's move on to next. Any doubts? So far, any doubts? No. Okay. Now let's move on to next. Now, having completed this, now the time is for integrals. Now let's move on to integrals. Chapter integrals. Here I am covering both definite and indefinite integrals together. Okay, fine. Listen carefully. Integrals. Moving on to the problems. See, as and how we'll take the problem, I'll discuss the concept. Let us proceed. Kindly pay attention and listen carefully. In this question number 15, I'm taking from question bank. They're asking us to find the integral value of this particular expression x square 2x plus 2. 1 by quadratic I have taken. As you know, in 1 by quadratic, we have got 26 forms. 3 without the root and 3 with the root. Now, first try to go for completion of square. See carefully. X square plus 2x plus 2 and 8. I just will copy the question. Now listen to the logic. What's there here? X. Write on x as it is. Then also in here plus. So write on plus here. What is half of 2? Half of 2 is 1. So what only got? 1. Then the square. I repeat. Whatever number variable you have, write on as it is. Sign also as it is. X multiple is half. Means I mean to say x multiple is 2. Take half of that. That is 1. But when you are doing this, make sure x square multiple is 1. Okay. If it's not 1, take common. Now, whatever you wrote here, that should be subtracted. Square is for 1. So minus out. Okay. Then plus 2. Now you see carefully. X plus 1 the whole square minus 1 square is 1 plus 2. Okay, now. So we'll get x plus 1 the whole square minus 1 plus 2 will be plus 1. So we are going to have this one. I can write as x plus 1 the whole square plus 1 square. I just wrote both in square form so that when I'm going to substitute here, see carefully, this entire expression will be x plus 1 the whole square plus 1 square. I mean to say this is of the form without the root. Both variable and constants are positive square, nothing but a square plus x square. What's the integration of this? 1 by a tan inverse of x by a plus c. So in place of a, constant 1. You're not going to compare a is equal to x plus 1. No, x plus 1. And this entire thing is a variable. Variable with variable, constant with constant. So a is equal to 1. And in place of x, what do we have? X plus 1. So since student may cancel, so let us, okay, x is replaced by x plus 1. So the answer will be 1 by a is 1. Then tan inverse of x is what? X plus 1 divided by a is 1. So the final answer is 1 by 1 is 1. 1 into this is the same term. So tan inverse of x plus 1 plus c. See the option, means the option for this is blue. Okay, I hope it's clear. I hope it is clear. Any queries, any doubts? No? Okay. Fine. Let's take the next question. Now let us move on to next problem. Question number 18 is integration of tan squared 2x dx. I have to integrate this. We know integration of secant square. So since we know integration of secant square x is tan x, so recall we have a formula secant square theta minus tan square theta is equal to 1. So solve for tan square, transpose this. So you get secant square theta minus 1 is equal to tan square theta. So this will be, I'm going from right to left. So since angle is theta here angle is 2x, so I'll get secant square 2x minus 1. Integration of secant square x is tan, angle is 2x. X multiple is 2, so divided by 2. Minus integration 1 is what? X plus c. Job done. Quite easily done. So that will be option C. Now, see question number 30. Integration of root of 1 plus sine 2x. 1 plus sine 2x we have to take. Now, surely we cannot think of applying any method of substitution because derivative of sine is cos. There is no cos you can see. Then how to go about? I will be giving you 4 formulas to memorize. Always remember that. First formula, as a note, I write here. What is 1 plus cos 2x? Or 2 theta, okay, 2x is 2 cos square x. What is 1 minus cos 2x? It will be 2 sine square x. What is 1 plus sine 2x? It will be cos x plus sine x, the whole square. Similarly, what is 1 minus sine 2x? It is cos x minus sine x, the whole square. A very important point to remember. Now see carefully. 1 plus sine 2x, yeah, 1 plus sine 2x is this. So I can rewrite square root as it is. Then I'll have cos x plus sine x, the whole square. Now root and square will get cancelled. Remaining is what? Cos x plus sine x. What is integration of cos sine x? Some rule applying. What is sine integration? Minus cos x. So you have to make sure, remember this result. So for this option B, W is correct. I hope this is clear. Any queries? Any doubts? Okay. Let's move on to next. Let us proceed now. Moving on to the next problem, dear students. See this question number 31. Question number 31 is integration of secant square x divided by cosecant square x. I know many students what they will do. No, integration of secant square x is tan x. Integration of cosecant square x is minus cot x. Wrong, terrible. Integration you cannot break. Some rule is there and scalar rule is there. Scalar rule is there. Like this, there is no such rule that you are going to take integration separately for numerator or denominator. Then what to do? Whenever we stuck with trigonometry, go back to basic. Secant is 1 by cos square. Cosecant square is 1 by sine square. Is it now the sine square will jump up? So we will have sine square x divided by cos square by 1 is what? Cos square x. What is sine by cos? Tan. Right now? But we don't know integration of tan square. But we know tan square is same as what? Secant square x minus 1. Integration of secant square is what? Tan x. Integration 1 is what? X plus c. Quite easily done. So which option it is? Which option? So for question number 31, we are having option D to be correct. Okay, I hope it's clear. Kindly comment. Any doubts? Any doubts? Is this clear? So any doubts? Okay, fine. Let us move on to the next question. See carefully. See, as it is not a PUC, I mean to say in PUC we have got MCQ and fill in the blanks where whether how you get the answer, they're least bothered. They just want the answer. So we can think of some shortcut formulas where we can get the answer in one line. So one such question I'm taking along with the formula. So as and how I take the problem, no, then and there itself I'll try to give the formulas also. Now, see this question number 37. It says integration of 2 sin x minus 3 cos x divided by 2 cos x plus 3 sin x. I want the integration. Just see carefully. Derivative of 2 sin x is minus 2. I repeat it. Derivative of 2 cos x is, just see here, if I take this as t. If I differentiate this, derivative is what? Minus 2 sin x. And what the derivative of this? Plus 3 cos x is equal to dt by dx. Correct? Now, see the numerator. Here we have minus 2 sin x, but here we have plus 2 sin x. Here we have plus 3 cos x, but here we have what? Minus 3 cos x. I mean to say terms are same, but signs are what? Opposite. Now for this we can have one formula. What? The formula is f dash by f whenever you want to integrate derivative by the function. It is always log of mod f plus c. But when you see here, no, derivative of this, which if I take as f, okay, I suppose we'll take f itself here. So we got here df by dx. So now see, these are taken as f, but derivative you see here minus 2 sin x is there, but here we have plus 2 sin x. Here we have minus 3 cos x, but we have got the plus 3 cos x. No problem. I can give one minus here and I can change the sign. Minus minus plus, minus plus minus. Now what's the answer? This minus as it is. Now this is the function and this is the derivative. You can see, no, both are matching now. So as what? Log of the function, log of the denominator. So log of the denominator, that is log 2 cos x plus 3 sin x plus c. Is this clear? In no time we have got the answer. That is in option C. Option Chalu is correct. Okay. Now you see one more question I'm taking. Question number 43. I mean to say question number 43. See carefully the question. It is integration of root x minus 1 by root x the whole square. We have to find the integration of this. Now be careful, you are not going to apply x power n here. Reason, power of x is not linear. Than that, linear. X if power is not 1, and we have 2x here. So how to solve, sir? First of all, you are not going to use x power n directly. You can see this as the form a minus b whole square. What is a minus b whole square formula? A square minus 2ab plus b square. So in place of a, we have root x. In place of, again, minus plus balance. In place of b, we have 1 by root x. So substitute here. Integration of 1 by, so I mean to say, a is root x. No, root x the whole square minus 2 times of ab. What is a? Root x. What is b? 1 by root x. Plus 1 by root x the whole square. Okay. Now simplify. Is it not square and root will get cancelled here? Square and root will get cancelled here. And root x by root x will get cancelled here. So we are going to be left out with x minus 2. Then 1 by x. So just see, have it written correctly. Yes. Now integration of x. Recall the formula. What is integration of x power n with respect to x? It is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. Power of x is 1 here. So put here 1 plus 1 will be 2 divided by 2 minus. What is integration of constant k? It is kx plus c. So integration of 2 will be what? 2 into x plus integration of 1 by x is what? Log mod x. And for all the integration, only one constant we are going to add. Not that, no, since I integrate for this, I'll add 3. Actually, we can add 3. Let us suppose for this, we'll add the constant to be C1, for this as C2, and this is as C3. C1 plus C2 plus C3, I can take bada wala C, that is capital C here. Okay, fine. So which option is matching with this? Let us check it out. Option B is matching. Okay, fine. So I hope there is no doubt. You can make a note of this. Yes. Now let us move on to next problem. See, question number 52. 1 divided by 1 minus cos x with respect to x. Now here, how are you going to proceed? Again, you cannot think of method of substitution because the derivative of cos is minus sign is nowhere present in the question. If you had sign here, we could have went for method of substitution. Now, how to proceed? And all the option, no, angle is x only. I mean to say they are not using any multiple angle formula with 1 minus cos x is 2 times of cos sine square x by 2. In option, angle is not x by 2. That means angle should not be changed. What we can do, no, try to bring this in numerator. Nothing but multiply and divide by its conjugate. That is 1 plus cos x here. Again here as it is. And here 1 plus cos x. Now 1 plus cos x as it is. This is the form a minus b to a plus b. What is dx as it is? What is a minus b into a plus b? It is a square minus b square. So this is your a, this is your b, again a and again b. So we are going to have 1 square minus cos square x. So what is 1 square minus cos square x? Sin square x. And this one numerator as it is was that 1 plus cos x. Correct? No, 1 plus cos x. Now it's a monomial, means a single term. This sin square 1 divide 1 also and cos also. So let us do that. 1 divided by sin square x plus cos x divided by sin square x. Now from here, what is 1 by cos? Secant square. I mean to say, what is 1 by sin? Cosecant square. Then plus cos by sin square. So cos by sin square. Can't I rewrite this one as cos? Sin square I can write twice. Now cosecant square as it is. Cos by sin is cot. 1 by sin is cosecant. Now formula. Integration of cosecant square x is minus cot x. Integration of cosecant into cot x is minus cosecant x. Plus c. That's it. So this resembles which option? Kindly check it out. Question number 52. Which option? Yeah, option A. Let us move on to one more question. Question number 56. Which says integral of e power x power 5 plus 5x power 4 plus 1. We have to integrate this. Now to integrate this, how to proceed? See, what is derivative of x power 5? 5 into x power 4. Oh, it resembles one formula. Integration of e power x into f of x plus f dash of x, which is equal to what? E power x, f of x plus c. So this formula can be applicable, but it should be addition of function and derivative. Derivative of x power 5 is 5 into x power 4, but there is an additional term. But no problem. Can't we rewrite the question as e power x into x power 5 plus 1 plus 5 into x power 4 dx? So very clearly you can see that this entire term is my f, And if I differentiate, what is derivative of x power 5? 5 into x power 4. 1 will be what? 0. So I'll get this to be what? F dash. So my answer is e power x into f. What is the f? What is f? X power 5 plus 1, then plus c. That's it. I hope this is clear. So which option? Check which option. Let's check the option. 56. Option D. Dom is correct. Now let's move on to the next problem. First, make it. I hope it's visible. Later on, we can copy. I always just give a space and stand so that later on when you're going to copy, you can means when you see back to copy. Well, I will always have a chance to copy the entire board. There is no problem from my end that I'm been standing in between the board and you. Okay. Now moving on to next. See carefully. Question number 57. It says we have to find integration of x into e power x dx. I'm not going to go for integration by parts. I'll give a logic here. Listen the shortcut. What is this shortcut? Where I lost my pen cap, marker cap. Anyway, we'll see later. So what is the formula? See, whenever you have integration of e power x into x power n with respect to x, the formula for this will be, and n is a natural number. Only there is applicable. What you can do is keep e power x as it is, then write on this x power n. Now differentiate this. Derivative of x power n is what? N into x power n minus 1. Again, find the derivative of this n as it is. Derivative of this is what? N minus 1 into x power n minus 2. Moves on till you won't get 0. Plus c. And the sign of this will be, another color, sign will be plus here, minus here, plus here, minus here. Okay. So again I repeat, e power x, x power n as it is. Then differentiate of the, you just differentiate till you won't get 0. Now you see this very easy you can get. E power x as it is. Now what you like? X. Yeah, x. Derivative of x is 1. After that, 1 is what? Derivative of 1 will be 0 over. And sign is what? Plus, minus. Okay. One more problem I will take from my end, so that will be very clear. Let's suppose I'm asking e power x into x power 5 to be different, means integrated. If you apply by parts, minimum 5 times you have to apply. Waste of time. So what's the logic? 5 in place of n is this 5. So it's an actual number. E power x as it is. Copy down x power 5. Now differentiate. Derivative of x power 5 will be 5 into x power 4 by using the formula. Derivative of x power n with respect to x is n into x power n minus 1. In place of n, we have 5. So 5 into x power 4. Next, keep 5 as it is. Now in place of n, we have 4. Derivative of x power 4 will be 4 into x power 4 minus 1 is 3. Okay. Next, 5 into 4 as it is. Keep as it is. X cube derivative. In place of n, we have 3. So derivative of x cube is what? 3 into x square. Next, 5 into 4 into 3. Derivative of x square is what? 2x. Nextly, actually I can multiply together, right? Just for expression sake, I'm just doing this. Then 5 into 4 into 3 into 2 as it is. Derivative of x is what? 1. But my recommendation, as soon as you are going to write next term, you can multiply. But since I'm teaching for the first time, I want you to learn properly. So now the sign is what? Plus, minus, plus, minus, plus, minus. Now what is the answer? E power x into x power 5 minus 5 x power 4. 5 4s are 20. X cube minus 5 4s are 20. 20 to 3 will be 16. Then again 20. See, as soon as I got 60, 2 is the one more multiple. 60 into 2, 120. Then 120 into this one, again 121. Right. Here is the sign is plus, and here it is minus. This is an extra problem which is not there in the question which I'm going to upload. I just thought, for x power 1, it may not look so what's use. But as soon as the powers increase, you can see 1, 2, plus, minus, plus, minus, plus, minus. Yeah, I've solved correctly. Kindly make a note. Any doubts? Are you clear with that? What whatever has been explained? Any doubts? Now let us move on to the next question. See carefully. Question number 68. Question says integration of e power 2x minus 1 divided by e power 2x plus 1 dx. We have to integrate. In all the option, we have got e power x and log all those things. Now how to integrate? Derivative of e power 2x will be and plus 1 will be e power 2x and 0. But I have got this. So what I can do, generator, just see. I'm going to multiply and divide by e power minus 6. See the benefit. I just want to have in both the terms e power x. Now see, if I multiply e power minus 6 into this, e power minus 6 into e power 2x, plus into minus minus, e power minus 6 into 1 will be e power minus 6. E power minus 6 into this, e power minus 6, then e power 2x, plus into plus plus, e power minus 6 into 1 is e power minus 6. Now from law of exponent, bases are same, we can add the power. Minus 6 plus 2x will be what? E power minus 6 plus 2x will be e power x. Again here e power minus 6. Minus 6 plus 2x will be e power x. And again here, oh, minus sign as it is. Now see carefully. See carefully. Again, I'm not going to go for PUC way. What is derivative? I take this as f. Derivative of e power x is e power x. Derivative of e power minus x is minus e power minus x. So this entire thing is what? F dash. So recall the given formula. F dash by f is log of mod f plus c. So answer will be log of mod of e power x plus e power minus x plus c. I hope it is clear. Is this clear? So which option it is? Option D. Now let us move on to one more question, number 86. For a while, I fold. Any doubts? Kindly reply. Any doubts? Are you following? Are you following it? Okay. Fine. Now moving on to the next question. Listen carefully. Question says integration of x into root of 1 plus 2x squared with respect to x. We have to integrate. Okay. Now, again, see carefully. I want you to learn this manipulation. What is derivative of x squared? X. 2x, but x is there. So here, again, see carefully. Now, since derivative of this is our f, which is 1 plus 2x square. Derivative of this is 1 is 0, then 2 as it is, x square is 2x. So f dash will be 4x. Correct now? X is there, 4 is not there. So what I can do is divide by 4 and multiply by 4. Now you see carefully. Now this is our f. One more formula I'm giving, f power n, and this is derivative of this. You can see now f is taken, this term, and then f dash of this is 4x. Nothing but this is our f dash. So the answer for this will be f power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. So 1 by 4 as it is. So in place of f, what do we have? 1 plus 2x. In place of n, we have what do we have? Power root. Means I mean to say root. Root means square root means what? Here power half. Correct now? N is equal to half. So put here f. What is f? 1 plus 2x. square. Then n is half. So half plus 1 divided by half plus 1. Half plus 1 is 3 by 2. Here also 3 by 2. So this 2 ones are 2 twos are 2 into 3 6. So 1 plus 2x square whole power 3 by 2 divided by 3 into 2 is 6 plus c. Okay, I hope this is clear. So it is based on this formula. Kindly make a note. Kindly make a note. So for this question number 86, option C is correct. Okay, fine. Visible, no? Is it visible properly? Yeah, visible. Fine. Now, let us move on to next question. Now, question number 91. See carefully. First, it is the board. Now, moving on to question number 91, a very elementary question I have taken. Can you just recall, no, if I have got a function which I want to integrate, that is f of x, integration of f of x with respect to x is capital F of x plus c, correct? They could have given this question at the beginning, but it's at the end. As I said, now I'm following the order of that paper, which is means the question bank. So this they have asked the 91st question. So let's see here. This we know the function which is to be integrated, we call integrand, and this symbol snake like we call integral sign, which says that you have to integrate, and this dx says we have to integrate with respect to x, and this f of x we call original function or primitive function, or we call antiderivative. And this c is called integral constant. Now what is happening here? Try to understand that whenever you want to integrate, no, integration, see, derivative of sine x is cos x, but integration of cos x is sine x plus c. Right? Why that c? See carefully. If, for example, we have got let us suppose x square, okay, half, and I want to differentiate. What's the answer here? Half as it is. X square will be what? 2x, correct now? Plus c. So mean to say 2 and half will get cancelled. Okay, then now I'll take one more example. X square by 2. Okay, I'll take here 2. Nothing wrong. I just want to make one thing clear. So if I differentiate, what I'll get here? If I differentiate, I'll get 2, then I get 2x, something but 4x. There's no c, sorry, 4x. Now, if I integrate this, what is integration of 4x? Take 4 out, then x into what? X square. Right now, take 4 out, integration, it's not x square, x square. If I keep as it is, by 2, by 2, no? Integration of x is what? X square by 2, 2 ones are 2 twos are, so answer is 2x square. We're not stopping like this. We are adding plus c. Why we are adding plus c? Reason is no. This derivative is not only for this. Even if I give you what is derivative of 2x square plus 3, as we got 2 as it is, x square will be 2x. 3 is a constant, so 0. So answer is what? 4x plus 0, nothing but 4x. So we are getting we have more than one function whose derivative is same. We have more than one function whose derivative is what? Same. So that's the reason when we are integrating it, we are unaware that this answer is this one or something else. That's the reason we add the plus c always, and we get the family of curves. So this is a parabola 2x squared. So the parabola 1, parabola 2, parabola 3, like this we can have below also. Okay, so you have family of parabolas. Now the question is on this only. The question is on this only. They have said that if this curve which is given here, question number 91 is given so, if it is given so, okay, function and write it here, then what they are saying is the equation of the parabola of curves in the given figure is, and the option for you, y is equal to integral of 1 with respect to x. Option B, y is equal to integral of root 3 with respect to x. Option C is y is equal to integral of root 3x dx. Then option D is y is equal to integral of 1 by root 3 dx. See, one thing you understand. If at all I want the curve of degree 2, I have to integrate degree 1 term, as you can see here. Here I had degree 1. To get degree 2, I should have degree 1. Similarly, if I have a constant here, if I integrate x, so if I talk with respect to polynomial expression, if my antiderivative is degree n, okay, I repeat, let I complete, okay, again, let I come again. If my integrand, if my integrand degree is n, then my antiderivative degree will be n plus 1, one more than the power of this, nothing but integrand. So when this is parabola, surely when I want to integrate, it should be what? Linear polynomial. That is there in which option? Kindly check. In which option we have linear polynomial? It is this option. So option C is correct. And if you want, you can integrate. This will be what? Root 3. Integration of x will be what? X square by 2 plus c. Whereas integration of this is what? X plus c. Integration of this is what? Root 3x plus c. And again, what is this? 1 by root 3x plus c. What are all this? Line. It's a line. Option A, B, and C. Antiderivative is what? Line. But it's not a line, it's a curve, it's a parabola. I hope this point is clear. Very good frame question. Purely on the concept. Fine. Now moving on to the last problem, then we'll go for definite integrals. Yes. For a while. Now let us move on to the next question. Kindly pay attention. See, question number 95 says statement 1. It is assertion reason type question. Statement number 1 for question number 95. What it says. So the statement number 1 says the antiderivative of secant x with respect to x. Antiderivative, nothing but integration, I can say no. With respect to this is log of mod secant x plus tan x. Okay, antiderivative. Without C there again, no problem. Statement number 2. See, they gave statement form, I wrote in mathematical form. Statement number 2. The derivative of log of cosecant x minus cot x. If I take the derivative, it is cosecant x. Now options are statement number 1. Statement 1 means option A is statement 1 is true and statement 2 is false. Option B is statement 1 is true and statement 2 is true. Statement 2 is a correct explanation for statement 1. Option C is statement 1 is true and statement 2 is true. Statement 2 is not the correct explanation for statement 1. Option D is statement 1 is false and statement 2 is also false. Now, if you just see now, if you have knowledge of integration, integration of this is log of mod secant x plus tan x is true. And since integration of cosecant x is this integration and differentiation both are reverse process of each other. So without differentiating, we can say, since we know that integration of cosecant x with respect to x is what? Log of mod cosecant x minus cot x plus c. This also implies that if I differentiate this on both the side now, see the power of concept. Without finding the derivative, we can comment. Okay, now see, if I take the derivative of c will be 0. Okay, I'll take derivative for this also. Some rule I'm applying. This is anyway 0. Now, see carefully. We know one concept, that integration and derivative both are inverse process of each other. Let us write it here. So I can say that here, when I have integration of f of x with respect to x, if I find the derivative, then integration and derivative will get nullified. I'll get only f of x. I get only f of x. Because of that reason, I can say that this two will get nullified. I'll get back what? Only cosecant x is equal to derivative of log of mod of cosecant x minus cot x, and derivative of c is what? 0. And this is what given here. Therefore, it is also true. But this is not a correct explanation. Reason, no. Here they are talking about secant, but here they are talking about cosecant. If they could have talked here, if instead of taking here cosecant, if they could have taken secant, then it's a correct explanation. Or here in place of secant, if they could have talked about integration of cosecant, that could have been correct explanation. So both the statements are true, but it's not the correct explanation. Therefore, which option? Option C will be the correct one. Okay, kindly make a note. Now we'll start definite integrals. More note in the sense I'm giving the space between you, means camera, and me, so that it will be completely captured, so that we can copy later. Fine. Let us just drink water. Whatever. Okay. Fine. Okay. Can we go ahead? Yes. Now let us proceed. Now we are in definite integrals. As you know, only limits will be coming in between now, and here the surely problem can be on properties of definite integrals. So let's focus one by one. Kindly focus and pay attention. Ready, all of you? Kindly listen. Moving on to the problem. Question number 72, I'll take one directly one rule of the first 72. Question number 72 says, if f of x is equal to 0 to x t sine t dt, then we have to find f dash of x. For this, let us add options also, so that the things will be clear. Option A is cos x plus sin x. Option B is x into sin x. Option C is x cos x. And option D is sin x plus x cos x. Okay, we have to find this. Now, understand carefully and pay attention. Coming to this now, method number 1, we got apply by parts and then get the answer. Apply limit, upper limit, lower limit. But I'll give one trick, shortcut. One formula you have to remember. What is that formula? See this. Since I want f dash, no, even if I integrate also, no, you again I have to differentiate also. So this is the concept. For definite integral, just give me a minute. I'll fill the ink. I think it's getting lighter. Yes, dear students, give me a minute. I will just fill the ink for the marker. So how you're feeling? Are you able to follow till then? Comment about that. No. If the things are followed by you all. Just give me a minute. I'll fill the ink. Yes. Yeah. We are ready now. Fine. Okay. So what it is saying? Question. I said no. We want derivative of f. F is given. So I'm going to give one formula for you. Listen carefully. What that formula says. Pay attention. It says that let us suppose that we have got a definite integral where the lower limit, upper limit, let us suppose psi of x and phi of x, nothing but lower limit, upper limit, both are what variable. And I want to integrate f of t with respect to t, and I want to apply derivative here. For this entire, I want to differentiate. What the theorem says is whenever t is there, see, you are integrating with respect to t, but you are finding the derivative with respect to x. Lower limit, upper limit has got x. So what this limit says is f. Now see, both derivative and integration of inverse process of each other. So f will remain f as we just discussed. Correct? No, we discussed that integration of f of x with respect to x. If I find the derivative of that, I'll get back what f of x only, because both are inverse process of each other. F remains f only. But now here got upper limit and lower limit. Then what we say is in place of t, upper limit replaced by upper limit, that is phi of x, into derivative of upper limit. Derivative of upper limit minus f of lower limit is psi of x into derivative of psi of x. That's it. So in short, what f is there? Wrote in place of t, upper limit into derivative of upper limit minus f is there. Then what? Lower limit is psi of x. Substitute in place of t, then differentiate. Now let's come to the question. Now if I differentiate this with respect to x, now f dash of x is equal to upper limit is x. So whenever variable t is there, replaced by x. So in place of t, x, then sign of in place of t, x. Now derivative of x with respect to x minus, no need to put anything. The lower limit is what? Constant. Derivative of a constant is what? 0. So why to waste the time in substituting? Okay. So anyway, in this case, since lower limit is 0, 0 into sine 0 is 0. But let us suppose I got 2. Then I should think of 2, sine 2, etc. But when I have to apply this logic, since lower limit is constant, derivative of a constant is what? 0. So I take it as 0. So we get derivative of x with respect to x is what? 1. So answer is x sine x. X sine x is in option B. I hope this is clear. Okay. Fine. Is it clear? Any doubts? Let us move on to next question. See, question number 78 that I take. Question says 0 to pi sine square x by 2 minus cos square x by 2 with respect to x. We have to go about. Now, how to go about this? See carefully. Degree for both is 2. Multiple angle formula or multiple angle formula we call cos 2x is cos square x minus sine square x. Right to left we have to go. We should learn the formula both the ways, left to right and right to left also. Now here cos square multiple is positive, sine square multiple is negative. You can see here other way around. Sine square multiple is positive, but cos square multiple is negative. So if I take minus out, minus into minus is plus, cos square x by 2. Minus into plus is minus, sine square x by 2 dx. Limit you can apply at the end, okay? Anyway, 0 to pi, that is right. Now minus. Now, whatever angle is it, double of that. Correct? Now, what is double of half? It is 1. So 2 into x by 2. I can think like this. 2 and half will get cancelled. X. So I will get 0 to pi cos x. What is integration of cos x? Yes, plus sin x, not minus sin x, plus sin x. Apply limit 0 to pi. So anyway here sin pi minus sin 0. Both will get sin pi is 0. Sin is also 0. So answer is what? 0. So which option? Let us see which option for question number 78. Option A. Okay, I hope it is clear. Let's move on to the next question. Now let us take a problem on even and odd concept. See carefully. Question number 79. Integral minus 1 to 1 x power 17 cos power 4 x dx. We have to go for this. Okay. Now whenever we have got upper limit, lower limit, same but signs are opposite, we are going to think about even odd function. Let us recall what is this even and odd function. Suppose, okay, the theorem says integral minus a to a f of x with respect to x will be 2 times of 0 to a f of x dx, provided f of x is what? Even function. Nothing but f of minus x will be equal to plus f of x. And 0 when f of minus x is minus f of x. So here that is f of x is even function. And here that is f of x is odd function. Okay. Now what is even function, odd function? As you can see, no, if I replace in place of this x minus x, I should get plus f of x. And if I replace x by minus x, if I get minus f of x, that we call the odd function. Now let us take 2 examples to understand, then we'll go ahead. Coming to even function. See carefully. We are saying that whenever you are going to have any function y equal to f of x, and if you are able to replace x by minus x, and if you are getting plus f of x, then we say it is even function. For example, cos x function, f of x is equal to cos x. Now here, if I replace x by what? Minus x. See what all happens? F of minus x, then cos of minus x. What is cos of minus x? Plus cos x. Plus cos x is what? F of x. Can you see? I got back the function itself. So cos x is example of even function. Okay, even function. Now if I talk about odd function, definition for odd function is again for y equal to f of x. If I replace x by minus x, f of minus x is minus f of x. Then we call it is what? Odd function. For example, f of x is equal to sin x. If I replace x by minus x, see what happens? F of minus x is sin of minus x. What is sin of minus x? Minus sin x. Correct now? What is sin of minus x? It is minus sin x. So minus will come out, and this thing is nothing but f of x. So minus of f of x. Therefore, f of x is equal to sin x. F of x is equal to sin x is odd function. And here f of x equal to sine cos x is, I mean to say cos x is even function. So it also means that modulus of x is even function. Secant of x is also even function. Coming to trigonometry, tan, cosecant, and cot are odd function. Sine inverse of x, tan inverse of x, and cosecant inverse of x. All of this odd functions. Okay, all odd polynomial, all polynomial of degree odd is odd function. All polynomial of degree even is even function. Now what this is saying is, if it is odd function, this entire limit will be zero. Means integral will be zero. For even function, it will be 2 times of lower limit is minus a, upper limit is plus a. The upper limit remains same, but lower limit will be zero. Okay, twice the area it will be. And every function will not be even and odd. Okay, for example, a power x, nano function. Nano means neither even nor odd. For example, f of x is equal to a power x. Now, if I replace x by minus x, f of minus x is equal to a power minus x. Now, whatever you do, you cannot bring this one denominator. So, I want to make power of a to be positive like this. Okay, you can just bring it to denominator. What is becoming this? This is what f of x is this. So, you get 1 divided by f of x. I'm not getting in numerator. I should get in numerator. You can see here. Okay, so it is neither even nor odd. This is the example, which is not equal to plus or minus f of x. Now come to this problem. See, I'm not going to verify like this. I just give the concept for you to understand. We are not going to verify like this. It's a time waste for us. Then how to do? Now before that, example for even function. Let's make it out here. Which are those? Secant x and all even power, where n is any integer. Coming to odd function, which are the examples? It can be cosecant x, then tan x. And I change the color. I'm giving this example because when I'm going to take the problem now, no, I'm not going to verify like this. I will remember this result, that which are the odd function and even function. So cosecant x, then now what next? Cot x. Coming to inverse trigonometric function, sine inverse, tan inverse, then cosecant inverse. And lastly, odd power of polynomial. Okay, it can be negative also. Means 1 by x cube is also odd function. 1 by x square is even function. Now come to this. Now you have got lower limit. Now how to know? I have to use this property. Whenever to use this property, whenever lower limit, upper limits are same, but signs are opposite. Okay. Now for this, how are we going to go about it? We are not going to check like this. See, understand. For odd function minus, for even function plus. Whenever you have product of function, no, we will go with school days. What in school days recall this sign? What plus into plus, plus. What is minus into minus, plus. What is plus into minus, minus. What is minus into plus, minus. So whenever plus is there, no, you think as even function. Whenever you have minus sign, no, think as odd function. So product of two even is even. Product of even and the product of odd and odd is even. Or product of even odd is odd. Product of odd and even is odd. Now you see x power 17, which function is odd, so minus sign. Here there is no sign, it means multiplication. Cos is even function, irrespective of this power, it's even function. So plus, minus into plus is minus. So it is which function? Odd function. For odd function, write again, is equal to odd function. For odd function, value 0. Job done. That's why I give the concept. Concept is very important. Until unless we are not perfect the concept, nothing can be done. Concept we have to learn. Okay. Let's take the next problem. Now I'll take a problem now involving addition after. Let us have this concept on the board as it is, so that it will be easy for me to explain the things for you. See carefully. Coming to question number 80. It says integral minus 1 to 1 x cube plus x into cos x plus tan power 5x with respect to x. We have addition term also. Now we are going to use sum rule. What the sum rule says. Okay. What the sum rule says. See carefully. Pay attention. Sum rule says we have to integrate one by one. So see this. Integration of -1 to 1 x cube. Then okay, dx I will write here. Aram se will go. Then integration of -1 to 1 x into cos x. Then plus integration -1 to 1 tan power 5x with respect to x. Now we have to check each of the integrand to be even or odd. Whenever power is odd, just now discussed, it is all which function? Odd function. So this is which function? Odd function. Lower limit, upper limit signs are same, but I mean to say lower limit, upper limit numbers are same, but signs are opposite. So I have to apply this concept. For odd function, value is 0. So this is gone. This entire value is 0. Now this also tan power 5. Tan is also odd function, power 5 is also odd. So again, this is gone, 0. This entire integral value is 0. Now here we should be careful. Product of two terms. X is which function? Odd, so minus. X into cos, so into sign. Cos is which function? Even, so plus. Minus into plus is minus. Nothing but which function? Odd function. Since odd, gone. Can you see? Because of the concept, how strongly we can finish. That's what concept is important. Kindly comment. Any doubts? I can see some students still press. Yeah. Any doubts? Kindly comment. Okay, let's move on. Next question. I think we have one more on this in that model means the question bank they have given. Now see, it's an assertion reason type question. Kindly listen carefully and pay attention. Ready? Coming to what? Assertion reason type question. Now coming to assertion reason type question number 94. Again, it is on even and odd concept. The question says assertion is integral. This is the assertion. In assertion, what they are saying is integral -1 to +1 to -1 to 1 2 dx integration is 4. This is the assertion. And reason R is integral -a to +a f of x with respect to x is 2 times of integral 0 to a f of x with respect to x provided f of x is even function. Then the option is saying assertion they have taken as a and reason they have taken as R. So a is false. Option A is a is false and R is true. Option B, a is true and R is false. Option C, a is true and R is false. Option D, a is false and R is false. That's what they are saying. Now see, coming to reason, this is from this concept only. So there is no doubt about this to be true. This is true. I have to talk about this. You see, as a constant there. I also want to highlight one point. Every even function is a constant function. Sorry, I repeat, every constant function is even function. Sir, how, sir? Let's take it here. Like any constant, f of x is equal to some number 8. If I replace x by minus x, what will happen? F of minus x, wherever x is there, replace by minus x, 8 means 8 only. What is 8? F of x. So plus f of x. Therefore, you can see very clearly it is even function. Purposefully, I have taken a numerical problem because I know if I take constant, things will be not so clear for you. Now, you see, if sir, many will say, sir, since you have taken plus, you got plus. If you take minus, you will not get. See carefully. F of x, if you like minus 8. Again, replace x by what? Minus x. Observe this. Wherever x is there, replace by what? Minus x. So f of, since x is there here, replace by minus x. Do we have x here? No. Minus 8 means minus 8. What is minus 8? F of x. So f of minus x is plus f of x. Nothing but it is what? Even function. So every constant function is even function. Note what? Every constant function is even function. Now come to this also. So 2 is a constant, so it's an even function. So directly for this I have to prove this, no? So let's take the left hand side. Left hand side minus 1 to 1 2 dx. Since 2 is a even function, so 2 times of 2 times of limit 0 to 1, then this 2 dx. Now 2 as it is, integer of 2 is what? 2x. Upper limit from 0 to 1. So 2 to the 4. Upper limit is 1. Correct now? 0 right here. Upper limit is 1. So 1 minus 0. 1 minus 0 is 1. 4 into 1 is what? 4. That's what they give. This is also true. And I can also say it's a correct explanation also. Okay. But let us see what they have given in the options. Okay, they're talking only about true and false. So here both are true. Then option C is correct. Option C is correct. Fine. Kindly make a note of this. Now, I'll be solving two problems, that is on greatest integer function and fractal part function, that came in the month of December for your PU board exam as well. This means last year 2025, but academic year is same 2025 to 2026. Correct now? Now listen carefully. I'll be giving you a short trick for this, so that in no time you can get the answer. Listen carefully. Just give me a minute. Yeah. Yes. Let us proceed. Listen carefully. So the next question, which came even in exam as well, question number 97. It says integral 0 to 2 greatest integer function. See, even in question bank, just they have given like this and give equal to. They have given like this, equal to. If you have mentioned rectangle bracket stands for greatest integer function only, then we are going to think with respect to this. Now give one formula, a short trick. What? In no time you can get the answer. Note number 1. Integral 0 to n greatest integer value of x is n into n minus 1 by 2, where n is a natural number. One more. Minus n to 0 greatest integer value of x is minus of n into n plus 1 divided by 2, where n is an integer. Sorry, natural number, not integer, natural number. Now it also means that, let us suppose the question, okay, first I'll complete this. So here you can see 0 to n, 0 to 2 in place of n 2. So n is equal to 2 if I use this formula. So what I'm going to have, 2 into 2 minus 1 divided by 2. 2 and 2 will get cancelled. 2 minus 1 is what? 1. Therefore the answer of this is what? 1. Okay, now as a note, I wanted to make a note. Let us suppose the question is something like this: minus 8 to 6 greatest integer value. Be careful. Here we have got minus n to 0 and 0 to n. Okay, so at 0 we have to surely break. So if the question is this, then how to solve? See carefully. This will be minus 8. At 0 our formulas are changing, no? So break at 0. Then again 0 to 6. Okay, now see, minus get balance, n is equal to 8. So for this, how to evaluate? Put n is equal to 8. Now, okay, don't think that this two should be same. No. This is separate formula. Okay, I've given for both n only. I can give here n and I can give here m also. Now here 0 to 6. Yeah, 0 to 6. In place of n we have 6 for this. If you substitute, then our answer will be for this this formula, no, minus of, in place of n we have 8. Correct, no? So minus 8 times of 8 plus 1 divided by 2. Then plus In place of in 6, 6 is here. 6 into 6 minus 1 divided by 2. We are going to substitute here. Correct? Now, just we split it. Now you see, 2 ones are 2 fours are. So I get minus 4 times of 8 plus 1 is 9. Plus 2 ones are 2 threes are. So 3 times of 6 minus 1 will be what? 5. So 4 nines are 36. 3 fives are 15. How much is this? Is it 21? Yeah, 21. 5 plus 1, 6. 2 plus 1, 3. Yeah. With minus sign. With minus sign. I hope this is clear. Okay. So this will be the shortcut for this. In no time we can get the answer. And I take an additional problem also. Now one more fractional part function. And then suppose one note. We have been given integral 0 to a to b. That's saying 0 to a to b. And you have been given x minus rectangle. Okay, I'll just give like this. Fractional part of x, where rectangle bracket is fractional part of x. Fractional part of x. Let's just write a bit more clearly. Fractional part of x. Okay, and it is also defined as like flower bracket. It's actually difference of x and greatest integer function. This is greatest integer function. Now for this also give a shortcut formula. In no time we can get the answer. And here this formula will work provided a and b are integers. Okay, both are black. Oh, okay. I've taken this. So both are what? Integers. See carefully what we are going to do. The formula for this is half of upper limit minus lower limit, provided both a and b are integers. And I'll take a mod here because it may not happen no that in taking the difference no you have taken in place of upper minus lower you have taken lower minus upper. As soon as I give mod no you are safe. Even if you write a minus b also no trouble. Now let us take a problem on this. Question number 103. Question number 103 says integral of -1 to 1 x minus fractional part. Again, they have flower bracket. This flower bracket is not this flower bracket. That's what I'm saying. In this question, when they have said, they could have mentioned that reason. Means what they stand for. Now, what I said, formula. See carefully. What is there? Lower limit is minus a. Upper limit is b. So half of upper limit 1 minus of upper limit b. B is 1 minus lower limit. Lower limit is minus 1. So answer will be half minus plus 1 plus 1 will be 2. 2 and half got cancelled. 1 is the answer. 1 is the answer. I think both were filling the blanks question. Yes. Yeah, 1. Filling the blanks question. It is 1. Now let us move on to the next. How is this trick? How will you find? In PU word, this question was asked on greatest integer function. Was it useful? Okay, good. There are some comments. Good to hear from you all. Yes. Yeah. I will also be going for next topic also. Who is this? I just see from the mobile. Yeah, definitely we'll go for the other concepts as well. Yes, Ishad Ahmed, then okay, yes, obviously we'll go for it. Okay, now let us move on to the last problem from definite integrals, and then we'll take differential equation. And today we'll try to wind up this all part. Okay. Now moving on to the next. Okay. Yes, yes, obviously. We will do it. Now, question number 104. If they are saying if integral 0 to pi by 2 sine square x dx is equal to pi by 4, and integral 0 to pi by 4 cos square x with respect to x is pi by k, then we have to find what is k value. Fine. Listen carefully and pay attention. Oh, pi by 4 or pi by 2? For a while, for a while. Both are pi by 2. See carefully. We have one actually property I thought to use, but for this, not directly, I can use one PUC concept only. We know one result. Integral a to b f of x with respect to x is integral a to b f of lower limit plus upper limit minus x. Correct now? Yes or no? X is what? Lower limit, x can be plus by lower limit plus upper limit minus the variable. So now, see carefully. This I can write cos square in place of x, what? Lower limit 0 plus upper limit minus the variable. Nothing but I'll get pi by 2 minus x. Correct? Yeah? So what I'll get? Pi by 2 minus x dx is equal to pi by k. And what is cos of 90 minus x? What is cos of 90 minus x? Sin x. Square remains as it is. And this value given in the data is pi by 4. Actually, I thought I'll give some other formula, but this is better. And it's pi by k as it is. K is equal to what? 4. Because pi and pi balances. K equal to 4. Job done. Okay. So with this, we complete definite integral. Now we'll take differential equation. Just I will drink water. But it's very good feeling to be in online and taking the class. Just let I drink water. Just give me a minute. Wow. Just give me a minute. Okay. Now we'll move on to differential equation. Let's start. What is differential equation? Okay, listen carefully. Some of the things. Then we'll start with the problems. Differential equation. I'll do one thing. It's already 2.5 hours. What do you say? Can we continue? Or we'll take differential equation for the next week. Next week again on next week also again we'll be having live session. What do you say? Should I stop or continue? It may take half an hour more, I think, to complete differential equation. Okay. So there's Ditya is saying next week, sir. Okay. Fine, then we'll stop it here. Fine. So we have finished today application of derivative. Then coming to integrals, both definite and indefinite, we have finished. Now we'll make sure differential equation. Along with that, we'll take some other chapters. Try to cover 3 to 4 chapters like this simultaneously. So fine. All the very best. Thank you for your thank you for your overwhelming support, and do like, share, and subscribe to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you.